Hello and welcome to Buildings of Tomorrow. My name is Jon Lester, and in today's episode we are talking about leveraging the building twin throughout the operations phase. I'm joined today by Kevin Bauer. He's the lead for BIM and Digital Twin at Siemens Smart Infrastructure in Europe. Kevin, thank you so much for joining us.
Hi, John. I'm really happy to be here today again.
It's an absolute pleasure to have you here. We've had a couple of discussions already around the digital twin and some of the experience that you and your team have had of really building and creating this digital twin throughout the delivery phase, bringing in additional detail that then enables you to start to leverage this building twin for more value through that operation phase. And that's where we'd like to focus on a little bit today, that operation phase. So after we've gone through the BIM planning process, that collaborative process, and we mentioned in the last couple of recordings, but you're also a certified trainer with Building Smart International. So, that BIM, that structured process and the collaboration around the BIM process is something that you know extremely well and that you're passionate about. So going through that process, then through that entire delivery phase, and we get to the operational phase, here is where some of those benefits that we've talked a little bit about for the owner, the operator, the responsibles for the building in that operation phase can really start to find additional value above and beyond what we would normally see in just the delivery phase. Let's start there a little bit on some of those values. Can you give us a little bit of an overview about some of the values that a digital twin can bring in that operation phase?
Yeah, I think that we have a lot of values a digital twin can bring, and there are different stakeholders to which we can address. In general, I think there are three main areas of values we deliver. The first one is the technical operations, where we can really help the facility manager operating the building more efficient by combining the operational data. For example, we get alarms and combine these alarms also with the BIM model to tell them exactly where it is. The second area of where we can deliver a lot of value is making buildings more energy efficient by combining, again, the operation data with data from the BIM model, identifying which rooms should have which energy usage to do, for example, gap analytics, and really identify where are some rooms which are not operating perfectly. And the third part is then helping the end users, for example, staff in hospitals being more efficient by, let's say, asset tracking, helping them finding assets or colleagues more efficient.
All right, perfect. I'd love to dive into each one of those categories one by one, because what I think is really interesting about the conversations we've had up until now is that some of these things you've actually done. And it's not theory, it's something that you've realized, you've gone through the process, and we see it working. So I'm interested to get a little bit of detail into those three phases, the support and value for the technical operations of a building, the energy efficiency and sustainability, and then finally the productivity and of the users of that building. So let's dive into the first one. Can you give us a little bit more detail around some of the things, some of the use cases, some of the values that Building Twin can bring for a technical operations manager or a facility manager, someone who's keeping that building running up and going every day?
Of course. I think at first I would like to talk a little bit about the problems, what we have today. We had a lot of customer discussions where, let's say, for me, it was really important as we started up, pitch the digital twin concept, ask them the first thing is, what problems do you want to solve? Yeah? Because at the end, it's, let's say, we don't want to just create products or solutions. At the end, for me, it's really important to solve problems and make the world a little bit better and help our customers. Mm-hmm. There we identified, especially in big hospitals or, let's say, in big industry complexes like hospitals, data centers, pharma, and industry complexes, which are really, really big, that the technical operations is often really inefficient because the people, they just, you can say, they don't know what's actually where in the building, because the buildings are often 20, 30 years old. And sometimes, let's say, there is an alarm popping up from the building management station saying the sensor with the ID XYZ231 is broken. and they just roughly know where this issue is. And then, let's say, what's the today's process and how to solve it is like this: they see there's a problem, and then they wander a little bit around. Yeah. So they, let's say, they don't make it really efficient because they also don't exactly know where the problem is. And therefore, they go searching where this called. So they just know this could roughly be in the second floor, and then they go somewhere in the second floor searching for it. And then they see, this is the product which is broken. Then they go back, look up, is this on stock or not on stock? And then they go back again back there, and let's say it goes like this. Yeah. So we identified the process, how they solve the problems today. They have a lot of waste in it.
Mm-hmm.
And the really important part which is missing is really giving them the experience exactly where is the thing. Yeah. So combining, let's say, the alarm management with a 3D model, helping them, let's say there's an alarm, and then they can jump into the 3D model and see, this is in a surgery room, this is in a hospital in a surgery room. So it's really important, the priority. And then they can look up, is this on stock? And then let's say if they have it on stock and they need to solve it really quickly, then they exactly also know where this is and how do they get there.
Yeah, I understand. And I can imagine, the example you used, there's a hospital, but there'd be many different types of buildings that have this similar situation, that are large facilities. They have multiple different applications spread across different places, any campus, universities, airports, hospitals, where not only is there too much to know the detail around everything, like you describe, you have a rough idea of maybe which building or which floor or which wing something is in, but then also not knowing what's there, what the application is this a space where you can enter easily? Is it a space where you need to wait or block it to make sure it's not being used, to do maintenance, et cetera, et cetera? That level of information is often not available today, if I understand correctly.
Exactly. Yeah. They just miss this information, and then let's say the processes are really inefficient. Probably another example, going away from hospitals more into pharma and industry. They have the same issue, but there is a little bit different. The most important for a production plant is to keep the production up and running.
Mm-hmm.
And therefore, let's say they normally close down their production just 1 or 2 weeks per year, which is over Christmas and over New Year's Eve. And then they need to solve problems as quick as possible or change products as quickly as possible. So for them, FDD, so fault detection diagnosis, is really important. They need to identify already in advance when something breaks. Mm-hmm. And then in these 2 weeks, solve as much as possible. And having this really good digital twin combining the operation data with the BIM, it helps them solve more problems in less time, so you can open up the production again quicker and make more money.
Yeah, and I can imagine also enabling that prioritization to know of the 10 things that need to be done today, or the 100 things that need to be done in this 2-week shutdown. What needs to be done first? Where are these spaces which are most critical, but also the most difficult to access, et cetera, so that you can prioritize not just with what happened first, but start to work more actively and more considered in the way that you go about your daily operation.
Exactly, yeah. I agree, yeah.
Okay, perfect. Thank you for that. The second one that you mentioned when we talked about a general topic or an overview of space where digital twin can add value is energy efficiency. Can you give us an example around how digital twin can be used to really attack this sustainability topic?
Yeah, at the end, let's say we all, I think, should work towards this goals, being energy efficient, cut down the CO2 level, that we all work together to achieve our Green Deal. It's a really important topic. It's where can the digital twin help to achieve this? It's today, often, let's say, the energy usage is not perfect in the buildings, although buildings produce 37% of all the CO2 level output. And what's really interesting is that when we combine the data, what we give get from the building management station concerning room automation or primary energy consumption. And we overlap this with a BIM model. Let's say creating the digital twin, we can then create cool dashboards showing up really quickly the energy consumption. For example, what's the temperature in this room? What's the CO2 level in this room? To really give the operators a quick overview what's the current state of the building. And let's say with these dashboards, then the FM guys can take quicker decision. And let's say if they see one room is overheated and this room is overheated for a longer time, then you can deep dive, especially just in this room. And then there's also a feature we call gap analysis, where you then can really just for this room analyze what's the should value and the current value. And if this is not matching over a long time, then let's say we should adapt the configuration of the automation systems, or in general, it is a trigger for us to do something because let's say the building is not configured perfectly.
So you're leveraging the understanding of the space itself. So not just the floor area, but the type of space, the 3D representation of that space, and use that to derive the best case scenario, and then making that gap analysis like you described to really identify the areas where not only are you maybe a degree off a set point or 2 degrees away from where you expect to be, but also compared to the total expectation within that space, and knowing a little bit about the energy requirements to make the changes that are being completed by the system to help you make that decision again and see where do we have to make changes, where do we need to even operate in a slightly different manner so that you can reach those goals.
Yeah, exactly. Yeah. It's about, on the one hand, we get data from the management station, the operation data, what's the consumption, what's the temperature, what's the CO2 level. And then we take the BIM models. But there we, on the one hand, also get really important information concerning what's the square meters, what's the cubic meters, but also what is the typical usage of the room. Is it an office area? Is it a meeting room? Is it an open office? Is it a bathroom? Yeah, depending, I'd say, for what you use the room. Yeah, the set points should also be different from an automation perspective. And we need to bring these two worlds together. To optimize it continuously. And then next to this, the BIM model, a 3D representation or 2D representation or whatever, is a really good tool for us to make good dashboards, because just Excel list or something like this is quite complicated to understand. Yeah? But having a cool dashboard showing these rooms are red, or the red ones are the bad ones, the green ones are the good ones, yeah, is much easier to understand for people. And let's say if you see these three rooms are red, there you have to do something.
Yeah, absolutely. And I think I really like the last point that you mentioned, because it's something that we shouldn't underestimate. In your opinion, how important is it, just this ability to bring information together and be able to make it more easily understood and easy to digest for a user? How much of a benefit can the building twin be when we use it to bring this kind of static data and dynamic data together and just make it easy to understand and easy to absorb?
Yeah, I think it's really crucial because today probably there are a lot of errors in buildings, or let's say buildings are not really optimized. But the thing is that people just don't know it. Yeah. And if you just don't know it, you cannot optimize it. And combining these two worlds, making a better visualization, and then from the visualization derive a dashboard and give the people really, let's say, not just the next step after this dashboard is give the people really a trigger or notification or a hint what they should do. Then it's much easier to solve the problems. Because today's like this, the FM guys need to really drill down and on their own identify, look up what could be the problem, etc., and it's really time consuming. Yeah? Yep. And now let's say we take the data, combine it, and now make dashboards, and then after the dashboards also give direct hints. Hey, this could be the problem. you can solve more problems in less time, or identify problems and solve problems which you have not seen before, because combining this big amount of data, buildings have so many sensors, it's just complex.
Mm-hmm.
And I think it's in general probably not possible, because it would take too much time.
Yeah, I understand. And I think that's one of the other really important points to mention, is that not everyone can be an expert in every system. And as buildings become more heavily automated, we have more operational systems that sit within them, and they all have hundreds and dozens of different sensors collecting information. The ability for us to use that information relies on us to understand it and make decisions from it. So any improvements we can make to simplify the visualization, to bring understanding quicker, to recognize a difference or a gap or a fault more easily, means that daily operation is not just easier, but it's also faster and more effective.
Exactly. There, you pointed out now a really important thing here. Having these 3D visualizations is much easier to understand. But we also identify from customers, they say there are this 2D view, schematic, and 2D ground floor plan views. Yeah, this is really complicated to understand. Mm-hmm. And the problem what we have still have is, let's say you have a building, and then you probably have somebody who is already working for this hospital since the last 30 years. Yeah? Of course, he understands the building perfectly. But a new young guy which comes in, it's a really hard cookie for him to understand the building, just after 2 years, or 3 years, he understands it. And we got now the feedback from our customers that they said, having this 3D model, like a computer game, helps them a lot in onboarding the know-how. Mm-hmm. Because, it's like a game. And the young guys, I'd say the people already love to play video games, and they somehow expect this also in their work area. Yep. But on the other hand, it's also helping them really quickly, like in a game, having fun, going through the building and learning game-wise how the building works.
Yeah, right. Like that, it's a term used probably a little bit too much, but gamification, just at least making it easier, making it more enjoyable, and maybe making it more interesting, using the latest technology to also help something which is part of their daily operation a little bit more enjoyable, a little bit easier to understand. Perfect. At the start, we mentioned 3 different types or 3 different areas of value from an operation digital twin. The last one you mentioned was productivity. So how using this kind of technology, having a really detailed 3D model that's integrated with the live data, can also help the users of the building and those within the spaces going about their daily business improve their productivity. Can you give us an example of a use case in this space?
Yeah, also the increasing the productivity is a really important topic. For example, at hospitals, imagine hospitals are opened. If you build now a hospital, it will be open the next 50 to 70 years, 24 hours, 7 days a week, 365 days. And, the main goal of a hospital is to heal patients. And therefore, it's really, let's say today, nurses and doctors sometimes have the problems that, let's say, their productivity is not perfect because, they have some small issues, like, for example, finding objects, let's say, like medical equipment, X-ray scanner, which you can, let's say, take around the building, or let's say, where's the next mobile bed, or let's say, where is the next colleague. And also to solve these problems, a digital twin with a focus use case, for example, on asset tracking, is a huge benefit for them, because let's say they also, what you need to enable this use case of asset tracking, you need on the one hand a representation of the building, here mainly 2D. You probably don't need 3D, but it's really important that this 2D is derived from a 3D model, that also these other use cases like technical operations and energy efficiency all have the same representation. But for the stakeholders of the staff, of the hospital staff, there you need a 2D representation is enough because it must be easy for them. But what they need is, on the one hand, this 2D representation, but then also this view where they see where is the next equipment, where do I find a mobile scanner, where do I find a mobile bed, where is the next doctor, where is the next nurse, so that they can be more efficient, because today a lot of time gets wasted through this. Yeah? Mm-hmm. And on the other hand, of course, this can get used by the hospital staff. But on the other hand, also the patients can then use this digital twin, and also the visitors, because were you ever in a hospital which was quite big and you didn't find the perfect way to visit somebody? So I experienced this already quite often. Yeah.
Yeah, and that's an interesting connection, because you mentioned all of these different use cases, whether it's technical operations, whether it's energy efficiency, whether it's productivity, should use the same representation, because that representation should be as close to the real thing as possible. But for this particular use case, just putting the simplest version in the hands of the user so that they can find what they need to find is a really important one. And I can imagine that in this use case, this is another example of where it's really about bringing data together from different sources and making the connection between that representation of the building and the space and that live information, whether it comes from different sensor types, whether it comes from automation systems or IoT or whatever it might be. You need to be able to combine and marry these worlds together to be able to fulfill that use case.
Yeah, I fully agree. Yeah? And this is really interesting in hospitals. But let's say, as you said, combine, let's say, the structural world with sensors. Also really interesting for office use cases. Yeah? Mm-hmm. Let's say, for example, you have a flexible working area, and let's say you want to have an app to show which rooms are used or which desks are used. Let's say you can order desks, and therefore, you need in the rooms IoT sensors which detect the movement, or let's say the occupancy, and then visualize it again in a 2D floor plan on a mobile app that, let's say, the office people can really quickly get a room or identify where to go.
Mm. Yeah, and what I really like about this use case, or what I find interesting, this is really not. This is starting to reach beyond the traditional operational technologies, because I can imagine here you have, like you just mentioned, presence detection, but also occupancy sensors. When we're talking about asset tracking, we need some way of really identifying the current position of a particular asset. What are the in your experience, what are the kinds of sensors and the different systems that you've had to integrate in fulfilling these kinds of use cases?
I think it's quite depending. Let's say for different use cases, you need different sensors. Yeah? It's when you think about these technical operations, it's really about this energy systems, because these sensors are quite distributed in technical central units, which you don't find that quickly. The same is for the energy efficiency. But when you think about this increasing of productivity, then it's also a lot of, let's say, room automation, having IoT sensors distributed in all the office areas and rooms, for example, that you track everywhere. On the one hand, the movement, the CO2 level, you have Bluetooth sensors, this kind of stuff. Yeah.
Yeah, and I think it's that combination which is essential to address that use case as you described, but then also more important, that ability to visualize and make it simple, because getting all of this different information from all these different systems can't be easily absorbed by a user of a building without some way of understanding it visually.
I fully agree.
I can't imagine, because as you described before, so often today, even for a technical operations manager who's known a building for a long time, when you're looking at spreadsheets and you're looking at device names that follow some naming convention, it's difficult, even if you know the building as well as your own house, to really know all of the details that you need to find. In the examples that we've used so far, How has that translated into daily operations? What's the feedback been from these discussions with customers after they start to recognize and absorb these benefits into their daily operation?
Yeah, I think it's the feedback is really good. And let's say what we see is, of course, depending on the kind of building you operate, different use cases are really interesting. Yeah, you think about hospitals, pharma industry, then this technical operations and energy efficiency is really a important topic. And of course, in hospitals also this increasing of productivity of the staff. But then, for example, in offices, it's really important to be flexible, enable this workplace experience use cases. So what's really important is, let's say, you really should think about what kind of building you operate and what are your strategic objectives. And then, let's say, you really have to think about which use cases can help you to achieve your strategic goals. Because just taking a use case, but let's say, don't thinking about if it helps to achieve a strategic use case could probably go in the wrong direction. Yeah. So thinking through this is really crucial.
And that's a great message, I think, to end the discussion on, because like you've mentioned before, when to build this digital twin, to start from the very start and invest the time and effort through the BIM planning phase, then through the delivery phase. We've discussed before, bringing in 3D scanning at all the major phases within that delivery phase. To do this and bring this investment and to get the real value, you have to have put the thought in and understood right from the very beginning what you're trying to achieve. Because without that, how do you know if the effort is worth it to a certain extent? Would you agree?
I fully agree. Yeah. It's really all about, let's say, thinking about in the early phase, what's the problem, and then how to solve the problem, and does this problem really solve some strategic target of you? Yeah.
Mm-hmm. No, perfect. Kevin, thank you so much for your time. As always, it's a really interesting conversation, and I love to hear those real life use cases of how we're starting to use the digital twin actively, and things that have been talked about, let's call it, or people are, we've had thoughts about what could be done. What I love to hear is real life examples. So thank you so much for joining us again today.
You're welcome. It was really a pleasure.
Always a pleasure for us as well. And I look forward to having some more discussions, because I'm still interested to hear a little bit more about, especially, one of the topics that I just mentioned that we talked about in the past, about this 3D scanning and integrating this almost as its own standalone discipline into this whole process. I'm interested to hear a little bit more about that. So maybe we'll organize another conversation. But until then, thank you again. And a huge thank you also to everyone out there who is listening or watching this episode. Remember to subscribe, like, share, comment. Keep your eyes out for more discussions with Kevin around the digital twin topic. And, of course, new episodes every week here on Buildings of Tomorrow. And until we see you there, we'll see you very soon. Thank you very much.